It's still a great pleasure to introduce Cesare Pastorino.
Oh, yeah.
Yeah, who has just moved to Berlin to take a postdoc. But he's a product of one of the great graduate programs for Newton Scholarship, Indiana. Works on bacon and experimentation. And what are you talking about today?
The electric spirit.
Gary?
Alchemy and the electric spirit.
Alchemy and electric.
The last paragraph of this general scholar. Okay, thank you very much. Thank you. First of all, thank you to Stephen, to Stefan, and Scott for inviting me to this great workshop, from which I'm learning quite a lot. In this half an hour, I will try to do mainly two things. So the first thing that I was asked to do was try to draw a little editorial history of the last paragraph of the Scholium. So I'm going through some of these manuscripts and draft manuscripts which are related to the composition of the last paragraph of the Scholium. And in the second part, I will focus on the issue of the alchemical origins of the electric spirit. And in particular, we'll look at one of these drafts I was talking about, which I think has quite an interesting alchemical connotation. I'll try to show how this manuscript is actually related to previous reflection by Newton on the vegetable spirit. So I think it's quite an interesting progression that I'll try to show you. So another caveat. Of course, I will tell you several things you will know very well, and so I apologize for this. But hopefully I will also try to tell you something that you don't know. So in January 1733, Isaac Newton was fully engaged in the final corrections and modifications for the second edition of the Principia. In a letter to his editor, the young Cambridge astronomer Roger Coates, Newton informed him that he was preparing and going to send him in a few days a Scholium of about a quarter of a sheet to be added to the end of the book. And someone is persuading me to add an appendix concerning the attraction of the small particle of bodies. Newton informed Coates that the appendix was going to take about 3/4 of a sheet. At the same time, he added, "I'm not yet resolved about it." On the 2nd of March 1713, Newton wrote again to Coates, sending him the general Scholium to be added at the end of the book. In his letter, he stated that he intended to have said much more about the attraction of the small particles, small parts of bodies, but upon second thoughts, he chose rather to add but a short paragraph about that part of philosophy. So the short paragraph Newton is referring to is in fact the one concluding the general Scholium. It is very well known to you all. The paragraph starts with a passing reference to a certain very subtle spirit hidden inside gross bodies. The operations of the spirits were responsible for a very large class of phenomena, and it is worth recalling Newton's text in full in the translation, Motte's translation of 1729. Because of these all-pervading spirits, the particles of bodies mutually attract one another at near distances and cohere if contiguous. And electric bodies operate to great distances, as well repelling as attracting the neighboring corpuscles. And light is emitted, reflected, refracted, inflected, and its bodies. And all sensation is excited, and the members of animal bodies move at the command of the will, namely by the vibration of the spirit, mutually propagated along the solid filaments of the nerves, from the outward organs of the sense to the brain, and from the brain into the muscles. Nevertheless, Newton concluded, these things cannot be explained in a few words. No, we are furnished with that sufficiency of experiments which is required to an accurate determination and demonstrations of the laws by which this electric and elastic spirit operates. It seems to me, quite a crafty literary and rhetorical strategy we as readers of the Scholium are presented here. Newton's rhetorical move showing and immediately after hiding his spirits from our view is quite compelling. Also, the choice of such a significant place, the final paragraph of the Scholium, and indeed of the whole Principia, is quite intriguing. Moreover, the existence and activity of the spirit is presented to us apodictically as a clearly established fact, not needing a particular justification. The rhetorical tone of the last paragraph is fully tuned to that of the second last. There, Newton summarized and listed what was certain about the cause of the power of gravity and the properties of gravitation. It is well known, there Newton was claiming to frame no hypothesis, but to build an experimental philosophy based on phenomena. It seems clear that the same rhetorical attitude entirely characterizes the last paragraph. We cannot doubt about the existence of the subtle spirit because phenomena confirm its existence. At the same time, it would be unwise to frame hypotheses about the specific laws governing its operations given the positive experiments we possess. So which experiments and phenomena did Newton have in mind when he was granting the existence of his subtle spirit? A look at the editorial history of the last paragraph of the Scholium can help us reconstruct Newton's thought on this subject. As it is obvious, this history overlaps that of the Scholium itself. At the same time, as Newton mentioned in his letter to Cotes, the last paragraph was preceded by attempt to write a more general appendix concerning the attraction of the small particles of bodies. For this reason, the editorial origins of the last paragraph needs to be and have been investigated among the documents which are clearly drafts of the Scholium, plus those related materials that instead seem to be more strictly connected to the appendix on the attraction of the small particles. So I'll start considering a draft of the general Scholium in two folios. It's Cambridge University Library Manuscript 3965, which is usually referred as Draft C. This manuscript contains a version of the Scholium in an advanced stage of composition. It is also clear that Newton, at a later time, and actually in the handout you can see a list of them, you can see the two lists of them, added a series of 12 propositions in the space that was still available in the pages. They appear in two groups, respectively 7 and 5, altogether forming something like a summary in the form of a list. The points made in the list reflect almost entirely the final content of the last paragraph of the Scholium, and there is no doubt that the propositions are an initial formulation of such paragraph. The most remarkable difference between the final version and these propositions is the establishment that the certain very subtle spirit of the paragraph is in fact an electric spirit. In the first group of propositions 1 to 3, Newton establishes that the small particles of bodies attract each other at small distances and when contiguous. Such attraction is electrical. The attraction is exceedingly strong and able to explain the cohesions of bodies. In proposition 4, Newton suggests that the attraction without friction operates only at small distances, while at larger distances particles repel one another. In proposition 5, Newton introduces the electric spirit for the first time as a very subtle medium permeating solid bodies. Proposition 6 states that this medium is most active and emits light. In proposition 7, Newton adds that the electric spirit is also set in motion by light as a vibratory motion, that is to say, as a form of heat. The second group of 5 propositions annotated on the following folio identifies the electric spirit as the medium through which vision and more generally sensations and animal motions are achieved, through which emission, refraction, reflection, and inflection of light are produced, the sociability and unsociability of bodies, in chemical operations is working, and finally nutrition itself is accomplished. Incidentally, Newton adds in proposition 9 that the vibrations of the electric spirits are swifter than light itself. So if the list was conceived as a summary of the properties and actions of the electric spirits, it seems that Newton initially attempted to establish the legitimacy of each of these 12 statements by means of phenomena and experiments. In fact, almost every proposition of the first group of 7 is associated with one or more experiments which are identified by a short title, almost in a form of a quick note. And I made a list of these experiments in the handout. The second group of propositions instead is not associated to any experiments. So as you can see, the experiments are only briefly noted down, and they are a various group. And the first ones I would like to talk is the experiments between 1 to 5, which are particularly significant in the economy of the propositions, because they are the phenomena that through which Newton establishes that the small particles of bodies attract each other at small distances or when contiguous. So these are all, as you can see, these are all experiments on capillarity of bodies, which were conducted and executed between 1706 and 1712 by the experimenter of the Royal Society, Francis Oxby, under the direction of Isaac Newton. So all these experiments, they're all reported in the Philosophical Transactions sometime during this period. So the experiments detailing the ascent of water in small tubes and in sponges were published in 1706 and 1708. Experiment 1 and 2, touching the ascent of water between two glass planes, appeared in 1710. And the experiment 5, which is particularly significant, discussing the direction of a drop of oil of oranges between two glass planes toward any side of them that is nearest pressed, appeared in two versions in 1711 and 1712 in the Philosophical Transactions. So these 5 experiments are in fact more extensively described in a second previous draft of the Scholium, also in Cambridge University Library additional manuscript 3965, usually referred as draft A. Contrary to the C version, draft A of the general Scholium is quite lengthy in its description of the capillarity experiments, but abruptly ends with a brief account of a second version of experiment 5 on oil of oranges, in which Newton and Oxby were able to quantify the attraction of the drop of oil of oranges from the opposing surfaces of glasses at various distances from the point of intersection between the glasses. This experiment was very much quantitative, and is actually quite an interesting experiment in which Newton and Oxby used some interesting and very clever experimental ideas to be able to measure the attraction between the glass, the surface of the glass, and the particle and the drop of oil. So the quantitative version of the experiment was published in the Transactions in the spring of 1712. Draft A contains only a short description without a lot of the details of the quantitative results. These details are present in another draft, which is called the Via Electrica. This is a further manuscript which testifies Newton's attempt to produce the appendix concerning the attraction of the small particles of bodies. It was first published by Rupert Hall in volume 5 of Newton's Correspondence. And the second part of the Via Electrica contained references to the same experimental material on capillarity already mentioned for draft C and draft A. And it largely overlaps the discussion of the material in draft A, but includes a more extensive and detailed account of the quantity of attraction between the drop of oil of orange and the glass planes. So that is to say, in the Via Electrica, Newton goes quite strongly into the details of the quantifications and the measurements that they did with Oxby on the attractive forces between the glasses and the drop of oil. The first part of the Via Electrica instead contained a discussion of the phenomenology of light, connected with light, which is related to the proposition 6 to 10 of draft C. The overlapping between the topic discussed in the Via Electrica and those listed in draft C is very strong. So there is a very strong parallel between these two documents. And it is so strong that it's possible actually from the Via Electrica reconstruct the experiment 8 referred to in draft C without any qualification is in fact the experiment on another of Hawksby's famous experiments on the production of luminescence from frictional, the friction that he produced on a sphere of glass with reduced atmosphere in it, which is a famous experiment in which he was able to produce luminescence. At the same time, electrostatic phenomena and luminescence. So, to summarize the discussion so far, first of all, it is reasonable to assume that draft A and the V electric are not entirely overlapping drafts related to the appendix that Newton was at some point wanted to add at the general Scholium. In any case, these two documents are clearly related. Secondly, given the closeness between the list of draft C and the final published form of the last paragraph of the general Scholium, it seems reasonable to assume that these lists were the moment in which Newton taught on the content of the last paragraph. And so when the moment in which this content finally converged and coalesced in some form. That is to say, I suppose, I don't know what's your opinion, that this is the last the moment in which the propositions become like a summary to write at the last paragraph. And at the same time, I think it's likely that in the first list of propositions, Newton added the short reference to the experiments, and then he just dropped them when he wrote the last paragraph, saying that he was not able to produce enough experimental material to prove the very subtle spirit of the paragraph. At the same time, things are not. I mean, the editorial history of this document, this paragraph, is not so simple like I'm making it like here. And so among Newton's papers, there are at least 3 other drafts that needs to be considered in relation to the last paragraph and the proposed appendix to the Scholium. And I'm referring to 3 documents. So two documents are related, and they are the Motu and Sensazione Animalium. And another document is the Vita Mor Vegetab. These two documents are present in the optical papers, and they are clearly related also to the evolution of the optical queries. So I will consider them later in the last part of this talk. And in particular, I will look at especially to the Vita Mor Vegetab. There is another manuscript which contains an analogous but not overlapping discussion of the electric spirit. And so while I was preparing this brief account of the editorial history of the last paragraph, I was quite puzzled by this document, because to my knowledge it's been mentioned only two times in the literature. I could be wrong. And actually, to my knowledge, it's really been briefly described by Richard Westphal in his Forces in Newton Physics, and also has been briefly mentioned by Maurizio Mamiani in his article 1991 on Newton's and Fenomeni della Vita. So, of course, this is, the reason why I bring this up is because I think there is really no better place than this workshop to be proved wrong. And so if you know of other places where this manuscript has been described, I'll be very happy to know about it. The interesting point about this manuscript is that Westphal, in his book, was considering him as clearly related, material produced for a draft of the general Scholium. And even more interestingly, Maurizio Mamiani, in this article I was mentioning, has suggested quite boldly that, in fact, this document is a proto-version of the general Scholium. So I just wanted to raise this issue here because it seems quite relevant given we are talking about these, And actually, I wanted to ask Stephen about this, but of course I will email. I didn't have time to do it before. I'll email him after the workshop. So you have the draft. You have the manuscript in the handouts. It appears in a draft. It's quite interesting because it appears in a draft of the last proposition of Book 3 of the Principia on comet motions. So proposition 42. And it's clearly a draft of that proposition to the extent that the last if you look at page 350 recto, the first 350 verse is not really belonging to it. It's just a previous version of the paragraph of the proposition. But 350 recto as a paragraph in which there is the final discussion on the comments, and which is still in a phase of elaboration. It's really not completed, and it's starting to be drafted in the form it will appear in the Principia of 1733. But after that formulation, the text goes on, starting with the expression gravitatis vires and proprietates, and the discussion that is developed there seems to be quite very much, some sort of early formulation of the Scholium, because there is initial discussion of gravity with a rejection of vortexes, and then there is a comparison between gravitational forces and electrical forces, quite a detailed comparison, the way the different way in which they operate and so on. And then the reason I was interested in it, there is another account of Oxby experiments on capillarity. And so there is another account of the experiment on the oil of oranges, which is actually slightly different from the one that is present in the Via Electrica. So Mamiani's assumption is that the draft of Proposition 42 of Principia with the Scholium-like discussion must have come before his intention to develop the Scholium proper, as stated in his letter to Coates of January 1713. So if this is the case, this early discussion of the electrical attractions and of the electric spirit is the first moment and development of the spirit of the Scholium. And then it will be followed by the attempts which are described in Draft A and the Via Electrica. At page 350 recto, you can also find the very interesting concluding remark of the draft. And this is the translation by Richard Westphal. Whether therefore will have undertaken to explain the phenomena of nature, which depends on the fermentation and the vegetation of bodies, and on the other motions and actions of the smallest particles among themselves, we need especially to turn his mind to the forces and actions of the electric spirit, which, if I'm not mistaken, pervades all bodies, and to investigate the laws that the spirit observes in his operations. The magnetic attractions will also need to be considered, since particles of iron enter the composition of many bodies. These electric and magnetic forces ought to be examined first in chemical operations and in the coagulation of salts, snow, crystal, fluxes, and other minerals in regular figures, and sometimes in the figures of plants, and afterwards to be applied to the explanation of other phenomena of nature. So there is already almost the last paragraph of the Scholium here. So this brief editorial history I reported so far is clearly limited to the general Scholium itself, as far as I was able to reconstruct. However, as several authors have I've mentioned in the past, and including Ted McGuire, of course, among others, it is very important to remember that Newton's account of the electric spirit is very much intertwined with the general discussion of the attraction of small particles of bodies, which after 1704 is mainly developed in the context of the queries of optics, first in the Latin edition and then in the second edition of the optics. So that really what we need to do is also, like someone said before already, when we look at the evolution of the discussion of the electric spirit, it's very important also to consider the discussion in the queries of the optics, because and the drafts of the optics are clearly related to the same editorial evolution of the Scholium. So, for instance, if we want to ask the question, what happened to the electric spirit after the Scholium? The history of the electric spirit after the Scholium seems to me is related to the development of what, from the second English edition of Optics of 1717, is numbered as query 31. And also, it's quite interesting to see that it's possible to tell quite two different stories if you look at Newton's published version of the query or if we look at his draft forms. So, what is usually called query 31 appeared for the first time in the Latin edition of 1607 as query 23, because it's well known Newton added 8 extra queries in the second edition. I believe it is instructive to compare these two published versions of query 31 a little more. So let's consider, for instance, the first introductory paragraph. The enunciation of the query itself did not change in the decades between the two editions. Have not the small particles of bodies certain powers, virtues of forces by which they act at a distance, not only upon the rays of light for reflecting, refracting, and inflecting them, but also upon one another for producing a great part of the phenomena of nature. It is to say, the content of the query is the problem of the non-gravitational forces operating inside bodies. It is worth remembering that in 1713, Newton had an answer for such query in the Scholium. In terms of the most subtle and active spirit, the small particles of bodies mutually attract one another at near distances and cohere contiguous because of the electric spirit. In both queries, Newton is much more cautious. It is well known, he affirms, that bodies act one upon another by the attraction of gravity, magnetism, and electricity. And these instances show the tenor and course of nature and make it not improbable that maybe there are more attractive powers than these, for nature is very consonant and conformable to herself. Newton does not consider here how these attractions can operate and uses the term only to indicate in general any force by which bodies tend toward one another. For Newton adds, we must learn from the phenomena of nature what bodies attract one another and what are the laws and properties of the attraction before we inquire the causes by which the attraction is performed. So Newton had also that gravity, magnetism, and electricity act as very sensible distances, so their operations have been widely observed. But Newton adds, it could be that apart from these forces, there may be others which reach to so small distances, which has hitherto escaped observation. This is the way the Latin edition of in the first paragraph of the query ends. In the English version of 1717, Newton adds a quite significant last line, if you keep in mind his long reflection and investigation on the electric spirit. Perhaps electrical attraction may reach to such small distances, even without being excited by friction. So this rather dubitative short statement is the only more or less explicit reference left in query 31, derived from the discussion of the electric spirit of the general Scholium. Newton attached to query 31 Hauksbee's experiments on capillarity discussed in the draft of the Scholium and appearing at the beginning of the 12 propositions on the electric spirit as evidence of the strong attractive forces responsible for the equation of bodies. Also, Newton included in a different query, query 8, Hauksbee experiments on light developed through frictional electricity. However, in that collocation, the query on bodies emitting light, the experiment almost lost its electrical connotations, I would say. So by the time of the second English edition of the Optics, the electric spirit, even the concealed form of the Scholium, that is to say, the certain very subtle spirit, had almost entirely disappeared from Newton's public texts. The story is quite different if you consider the draft of the optical queries. And looking at these unpublished manuscripts made quite clear that for a while, Newton continued to consider the options of an electric spirit very much in the vein of his discussion at the time of the general Scholium. What is clearly an early revision of the Latin queries, Newton modified query 23, the last query, introducing two subsequent queries, 24 and 25, and these are found in the optical papers. Both texts draw on some of the 12 propositions of draft C of the general Scholium. So for instance, query 24, Quaestio 24 in the Latin version, asked if may not the forces by which the small particles of bodies cohere and act upon one another at small distances for producing the above-mentioned phenomena of nature be electric? For the particles of all bodies may abound with an electric spirit, and if there be such an universal electric spirit in body, certainly it must very much influence the motions and actions of the particles of the bodies among one another, so that without considering it, philosophers will never be able to give an account of the phenomena arising from those motions and actions. And so far as this phenomena may be performed by the spirit which causes electric attraction, it is unphilosophical to look for any other cause. So also the provisional query 25, following the following query, which is in the draft, focus on the power of the very subtle, active, potent, and elastic spirit to emit, refract, and reflect light, perform electric attractions and fugations, explain equations of bodies, and regulate the motions of the small particles of bodies. Most interestingly, though, the query developed in the second part, looking at the issue of vegetation. The spirit may also be of great use in vegetation, wherein three things are to be considered: generation, nutrition, and preparation of nourishment. So, in the last part of this talk, I would like to actually look at the link between vegetation and the electric spirit. This will also mean to consider the place of chemical phenomena and operations, which for Newton, as we will see, are conceptually quite closely connected to the vegetative operations of nature. So it can be useful to go back to Newton's early reflections on vegetation, which can be found in one of his alchemical texts, Nature's Obvious Laws and Processes in Vegetation. The importance of this manuscript has been stressed in the past by Betty Jo Titter-Dobbs in a book on Genius, Faces of Genius, and most recently have been again emphasized. Yes? Okay. Yeah, I'll try to conclude quickly. So most recently, William Newman has discussed this text quite a lot. In this text, Newton makes a quite important distinction. According to him, nature's actions are either vegetable or purely mechanical. Purely mechanical actions are the sensible changes that take place in the textures or the gross matter. That is the domain of sophistical or vulgar chemistry, only based on the mechanical coalition separation of particles. Vegetation, according to Newton, has to resort to some further cause. Newton says the difference between mechanical actions and vegetative actions is vast and fundamental, because nothing can ever yet be made without vegetation, which nature used to produce by it. There is, for Newton, a more subtle, secret, and noble way of working on vegetation, which makes these products distinct from all other. And the immediacy of these operations is not the whole bulk of matter, but rather an exceedingly subtle and imaginably small portion of matter, diffused to the mass, which is, if it were separated there, would remain dead and inactive. Moreover, the ingredients entering the operation of vulgar chemistry can always be recovered and returned to the original state. A metal can momentarily be dissolved in a solution, but can always be precipitated and returned into its original form. This is not the case for vegetation. True vegetation implies a complete change of the essence of the body. So as Larry Principe, for instance, has recently suggested, a very similar view is present in the chemistry of Johann Battista van Helmont. Again, Van Helmont identifies chemical operations involving superficial changes, which he calls larvae or masks. However, as Principe clarifies, a second type of material change happens when semina are involved, seeds are involved. In Van Helmont, semina operates through odors and ferments. Through such instruments, semina produce change of essence. For instance, as Principe reminds us, water, Van Helmont basic substratum, can be transformed into all other substances in the world. So it's truly remarkable that 40 years after the discussion in the Nature's Obvious Laws of Vegetation, which is already considered belonging in early 1670s, this Helmontian idea resurfaces again in connection with the electric spirits and electric forces. And the test I have in mind is the draft of Query 25, I was referring before, and a 14 Latin text, which is the Vita Mor Vegetab, which was for the first time published by Maurizio Mamiani and Emanuele Trucco in 1999, and has not received very much attention so far, I think. The Vita Mor Vegetab begins with a discussion of acid solvent, menstrua, and of solutions. The operations of such solutions can be explained in terms of electrical attractions. For instance, Newton states an acid solvent can dissolve a dense body because through attraction the particles of the solvent permeated the interstices of bodies, releasing its particles of last composition, which is Newton's highest level of material structure. This action produces an apparent dissolution of body. However, the acid particles are not small enough to enter the pores of the body particles and dissolve them further. They remain in the solution with their nature unchanged. In the case of a metal, after precipitation, they can be fused and the original metallic body can be recovered. That is to say, here Newton is explaining the level of vulgar chemistry, the one he was referring already in the alchemical papers. However, Newton continues, if a certain more subtle spirits are excited during the process, they can actually enter the pores of the particles of last composition, dissolving and separating them into smaller particles of penultimate, second to last composition. This is the level of vegetation. The particles of penultimate composition can change back to last composition only through a process of generation. So dissolution of this type are usually called putrefactions and corruptions. In a truly Helmontian vein, Newton states that only ferments can produce such operations. The ferment is a vegetable body. This is a quote from this draft. A vegetable body rich in spirits able to penetrate the pores of the parts of ultimate composition, dissolve them, and through this dissolution produce new spirits of the same type to which putrefaction completes. At the end of this process, the body is dissolved in its smallest parts, partes minimas, and at this stage, the original form and essence of the body is lost, and through generation, it can achieve countless new forms. So in summary, putrefaction breaks the body in its smallest part, while generation recombines the smallest parts and restores them to a new order. And it also makes the case of gold. It's very interesting because it's something they already mentioned in his letter to Boy on this very similar topic. So also gold can be, Newton says something like, if gold has a fermentative essence, we could change gold to everything we wanted. So it is impossible to miss, I believe, the unmistakable Helmontian character of Newton's explanations in the Vita Mor Vegetab. Remarkably, however, the Helmontian spiritual ferment is endowed with an electric power of attraction. All operations of the ferment can be explained by means of electric attraction. This is more generally true for the less subtle phenomena of chemistry. So all this discussion is based on electric attraction, on the electric spirit. It's then clear that what Newton has in mind, this explains very well, at least at this stage of the composition of this of the electric, the scholium and the electric spirit. What Newton has in mind when he refers to the attractive forces between the small particles of bodies, he's referring to the action of the ferments and these attractions in the chemical sense. So the electric spirit of the ferment is so subtle that it can operate on such particles, on the smallest particles of bodies, allowing the process of vegetation. So I'll stop here because I'm already quite outside my time.
We have about 10 minutes for discussions. May you go first?
So I have two questions which I think are unfortunately a little orthogonal to your discussion. But one is just, is there any connection between the issues you're discussing and Newton's decision to remove hypothesis 3 from the second edition and replace it with the third rule? Now, there might have been, in that case, there might have been reasons to put in a third rule that have nothing to do with changing views about the uniformity of matter. But I'm just curious whether that's...
I really don't know. My answer
Okay.
is very simple.
So that might be just an
But it's an interesting suggestion now.
And the other question is just quite a general one in terms of thinking about other forces that are applying at shorter distance scales. How is it that Newton's thinking about these, and flames will be flying out of my mouth, as Niccolo said earlier, in terms of the quantitative structure of the forces? Does he imagine different kinds of quantities that these forces will depend on other than mass and distance?
Well, he's saying that the electric forces operate to the surface, while gravity operates to volume, proportionality to volume. The electric forces are proportional to the surface of the bodies.
But the question might be, is there anything like another parameter that would appear that would determine how that force operates? So the gravitational force just depends on mass and distance. One conception of force might be that you have forces that vary in a different way with distance that would be important at short scale. A different conception would be there's something like a replacement for mass that determines how strong the force is.
Well, in his quantitative analysis of the electric force in the experiment I was referring to, they try to develop, to see how the force varied with the distance, and they found it was varying with the square of the distance from the origin of the experiment was built with these two parallel glasses eating in a corner. And the drop of oil was moving toward, because of capillarity, was moving toward the point of attraction, toward the point of intersection between the glasses. And what Newton did was to very ingeniously find a way to calculate the force. This force changing the position of the glasses. At a certain point, the drop of oil would stop because of the gravity. And so he was able, given the weight of the drop of oil, to calculate the attraction at different points, and he found that was varying as in the inverse square of the distance from the origin.
Can I say something about it? We have very little time, and there's actually a list, so I'm going to go to Dimitri. Sorry.
I'll be quick. Thank you so much, Cesare. You're doing remarkable work, which is so detailed at the absolute cutting edge. What I just wondered, to try and connect this to what a lot of people have talked about. What I particularly liked was that quotation when he says there are either vegetative or mechanical forces, and it made me think of a passage I had recently been reading, which is Newton's draft to a letter to the editor of the Memoirs of Literature in 1712, responding to Leibniz, where Leibniz says that Newton's gravity must be some kind of occult quality, but Newton says, and why may not be said, the same be said of the vis inertiae, and the extension, the duration and the mobility of bodies, and yet no man ever attempted to explain these qualities mechanically, or took them for miracles or supernatural things. Now that sounds like Newton's saying something structurally similar. We have vis inertiae and we have mechanical causes. But what is particularly interesting, I think, here is that Newton says we shouldn't be surprised at all about this, right? And of course, that feeds into the biggest revolution in the historiography of science over the last 30 years, is that we now know he was right. No one should have been surprised by this. I made a list. Is there any major English natural philosopher of the second half of the 17th century who doesn't believe in active forces. So I wonder if you could connect this to the historiography. I mean, in the sense that when Betty Dobbs did this, for her it was still, you know, we must look for the Neoplatonic tradition or the occult tradition and so on. Newton says he's doing mainstream stuff.
Well,
where do you see his place?
No, what I was telling here is a story which is the last part of something that Bill Newman has already clarified, I mean, quite strongly clarified in certain parts of his work. That is to say, this is that you know, these considerations here derive quite clearly from Newton's reading of the alchemical, you know, working on the alchemical text of George Starkey, Irenaeus Philalethes, because some of these passages I refer to in the Vita Mor Vegetab can be found in discussions in the letter to Boyle I was mentioning before. William Newman has clearly showed that those references and, you know, the way in which the structure of matter for Newton was very much informed by his alchemical knowledge of Irenaeus Philalethes, and there is a overlapping between, you know, the way in which Newton constructed his matter theory and the alchemy of Irenaeus Philalethes, which you know is quite complex, and this is something this discussion in the Vita Mor Vegetab is something I found only recently, and it's something that needs to be connected to that discussion. But the work is there, you know. The main this is clearly the last step of that, and well, this basically means that, you know, these discussions means that the active, at least in the moment in which it was, you know, working on the electric spirit, the forces it was thinking about were those coming from, you know, Del Monte ferments, endowed with you know, the power of the ferments, which for a while for Newton was probably electrical, I think.
There's apologies to everybody on the list. A very quick common question.
I don't know if I can do that because, well, we'll see how. Basically, the question is related to: do you see, or can you say anything more about, since a lot of the general scholium has this sort of theological aspect? Is there any link or connection between God and this pervasive spirit that you see? I know Dobbs has her, you know, Arian theory. What sort of?
I'm agnostic.
Yeah.
No, I don't know. It's a very interesting question. I'm not qualified enough to answer.
Because I see like more as pervasive spirit. But we don't, like, you know, we're pretty sure that that's not what Newton's going for. But is there kind of a?
I don't see why you wouldn't have thought that this, you know, this activity of matter would come from, well, from God for sure.
Yeah.
But I don't know how would, you know, to the details of this. I don't know.
Thank you very much, Cesare.
Yeah.